In section 110, we're going to focus on lines. We'll focus on quadratic graphs again at another point in time. Now you've learned slope before. Slope is how steep a line is. And one of the definitions we gave you for slope was rise over run. Rise being how far you go up or down, depending on if the slope is positive or negative, and run is how far you go to the right. So if I give you this line not only has positive slope, but it's pretty steep. So let's say maybe the slope is 7. So a slope that's less than that, like let's say I had a slope of 3, the line won't be as steep, but the slope is still positive. Maybe if I gave you a line and I said the slope was 1/2, let's make that look a little bit better. It's still going up from left to right, but a slope of 1/2 is not going to be very steep at all. The same holds true for negative slopes, except negative slopes are going to be lines that go down from left to right. The bigger the number, the steeper the line. The smaller the number, the less steep it is. Because 0 slope is just a horizontal line. And then vertical lines, those were the ones that we said had no slope. Or we also called it undefined slope. We like the word undefined better. So outside of rise over run, you also learned the definition for finding the slope of a line. The rise is also known as the change in y. So it was y2 minus y1 over the run was the change in x, x2 minus x1. The last definition, the little triangle, is the Greek letter delta. And in mathematics, delta means change. And you know change means subtraction. This is going to lead us into a calculus concept later in the school year. Now the thing I want to remind you about finding a slope is that the order in which you do rise over run doesn't matter. Now remember that in your ordered pair, the ordered pair is always x comma y. So in order to find the slope, you can do change in y as 5 minus 1, or you can do 1 minus 5. For the denominator, change in x, you can do 8 minus 2, or you can do 2 minus 8. The thing you have to remember is that you do have to be consistent about the order in which you do this. I want you to notice these match up as an ordered pair, and then if I flip the order, the number on top needs to be in the same ordered pair as the number on the bottom. That's what I want you to be careful of. Because either way that I do this, I get 4 over 6, which is 2/3, or if I do it the other way around, I get negative 4 over negative 6, which still reduces to positive 2/3. If you're not sure if the answer to a slope should be positive or negative, you can always graph the points. 2, 1 would be here, and 8, 5, let's see, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 8, 5 would be here. So if you draw a line through those 2 points, you see that the line goes up from left to right. So your answer better be positive. Another way of finding the slope, or I shouldn't say that, there were a couple ways of writing the equation of a line. And outside of SlopeIntercept form, one of the other ways we had of writing the equation of a line was called Pointslope Form. And Pointslope Form, we probably learned it after we learned SlopeIntercept form. The thing about Pointslope Form is that this is going to be a more useful method for us in order to learn calculus. Pointslope Form starts as the slope formula. The only difference is instead of calling it y2 minus y1, I just called it y minus y1. And I call the denominator x minus x1. Well, if you think about this like a proportion, and then you cross multiply, you're going to find out that y minus y1 is equal to m times x minus x1. This is the more traditional way of writing point-slope form. It's the form of a line that we like to use when we know the slope of the line and we know a point on the line. So now let's find the equation of a line with a given point and slope. If we use point-slope form, y minus y1 is equal to mx minus x1, the point you're given gets plugged in for x1 and y1. So we're going to do y minus negative 3 is equal to negative 1/2 x minus 1. And then anytime you have two negatives, you're just going to make that a positive. So this would be the point-slope version of the equation of the line. If you want to change it back into standard form, that's what my book here does. You can distribute y plus 3 is equal to negative 1/2 x plus 1/2. You can add 1/2 x to both sides, and you can subtract 1/2. So let's see, 3 minus 1/2, that's 6, so minus plus 5/2 equals 0. And we don't like fractions in equations, so if I multiply everything by 2, because that's the denominator of two of the fractions, I can get rid of the fractions. So I could get x plus 2y plus 5 equals 0. This is called standard form, or sometimes they call it general form of an equation of a line. And for those of you taking the ACT this year, a lot of times you'll be given equations in this form and you'll need to convert them to another form in order to get useful information. The other nice thing about knowing the slope and a point on the line is if you want to do a quick sketch of the graph. So if I quickly put a point at 1, negative 3, and then the slope is negative 1/2, that means to sketch more points in the graph, I go down 1 to the right 2. Or I could go up 1 to the left 2. And there's my quick sketch of what that line would look like. The first form of an equation of a line that we probably learned in algebra was slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. And the y-intercept is a point on the graph where the x-coordinate is 0. So if you think about our point-slope form, if you plug in 0 for x1 and y for y1, that would look bad because it would say 0. But not 0. I shouldn't have called this y. I should have called it b. Sorry. Because we used b in slope-intercept form. Okay. And then I changed that to b. I would have y minus b is equal to mx. And then I would add the b, and I would get y is equal to mx plus b. And that's where slope-intercept form comes from. Let's also do a problem where we find the equation of a line if I'm given 2 points that lie on the line. So in order to write the equation of a line, whether you write it in slope-intercept form, point-slope form, or general form, if you're given 2 points, you need to find the slope of that line first. Now remember, I said it doesn't matter what order you do your subtraction as long as you're consistent. So if I'm going to do negative 4 minus 2 in the numerator, I have to do 3 minus negative 1 in the denominator. So I'm going to get negative 6 over 4, which reduces to negative 3/2. So the slope is negative 3/2. If you're not sure if you did that right, remember one of the things you can do is you can graph the 2 points and see if the line goes up or down from left to right. Well, now, in order to write the equation, if I know the slope and I know a point on the line, I can use point-slope form. But which point do I use? And the answer is, it doesn't matter. I could do y minus 2 is equal to negative 3/2 x plus 1, because I plug in minus a negative 1. Or I could do y plus 4 is equal to negative 3/2 x minus 3. And even though these two equations look different, I claim to you they're the same. if I distribute. I hate fractions, so maybe I'll multiply everything by 2. And then I'm going to get everything on the left-hand side of the equation. I get 3x plus 2y minus 1 equals 0. Now let me do this with the equation on the right. Y plus 4 is equal to negative 3 halves. Oops, try that again. 3 halves x plus 9 halves, because I multiplied 2 negatives. I hate fractions. I'm going to multiply everything by 2, so I get 2y plus 8 is equal to negative 3x plus 9. And then I'm going to add the 3x. I'm going to subtract the 9, and I end up with the exact same equation. So it really doesn't matter which point you use in this particular problem. Now let's talk about using slope-intercept form. I want to find the equation of the line with a slope of 3 and a y-intercept of negative 2. Well, when you're given the slope and the y-intercept, all you have to do is plug it into this equation. So y must be equal to 3x minus 2. Now in part B, let's find the slope and y-intercept of the line 3y minus 2x equals 1. In order to find the slope and y-intercept, we want the equation to be in slope-intercept form, so we want to solve it for y. So you're going to add the 2x, you're going to divide everything by 3, and then the slope must be 2/3, and the y-intercept must be 1/3. Vertical and horizontal lines are extremely important. They're going to show up all the time. We use them a lot. And really it's just a matter of having the equation of a vertical and horizontal line memorized. It's just going to make your life a lot easier. Vertical lines always have the equation x equals some number. It's whatever number it goes through on the x-axis. So for example, let's say I gave you this vertical line. This would be the vertical line x equals 2 because it goes through 2 on the x-axis. Remember, the vertical line never touches the y-axis unless it's on top of the y-axis. Horizontal lines always have the equation y equals some number. So if I give you this vertical line, it would be the equation y equals 4. Because it goes through 4 on the y-axis. So there are different ways we would give you for telling you an equation for a vertical or a horizontal line. So in example 5, let's start by looking at A. It says an equation for a vertical line through 3, 5. Well, remember vertical lines are always x equals. And x equals the x coordinate. Well, it's going to be 3 because if you have a graph and you graph 3, 5, which is over my writing, and then you draw a vertical line through it, you're going to go through 3 on the x-axis. This same equation we can give to you by stating an equation for a vertical line with x-intercept 3. Well, if it passes through 3 on the x-axis, then the vertical line must have the equation x equals 3. For horizontal lines, let's say I say the equation for a horizontal line through 8, negative 2. Well, horizontal lines are y equals the y coordinate. Well, in this case, it would be negative 2. But another way I could state that problem is an equation for a horizontal line with the y-intercept of negative 2. So if we go back up here to this one, let's see, 8, negative 2, let's see, 1, 2, 3, 4, 5, 6, 7, 8, negative 2. And we set a horizontal line. It's going to go through negative 2 on the y-axis, isn't it? And that's why the equation is going to be y equals negative 2. Outside of slope-intercept form and point-slope form, there's another way of writing the equation of a line. We've already run across this in a previous example. It's called the general, or sometimes it's known as the standard equation of a line. Sometimes it's written in this form, ax plus by plus c equals 0, and sometimes it's written in this form. And it kind of just depends, or I shouldn't say negative c, because sometimes they just say c. It kind of depends on the author of the textbook you're using on which one is the right one. On the ACT, you'll see equations of lines given in either of these formats. So for the last example in this video, we're going to pretend like all of a sudden all the electronic everything in the world stopped working. There are no calculators, no phones, no internet, no nothing. But you're in my little math tribe, and I give you this problem, 2x minus 3y minus 12 equals 0, and I say graph it. If you can't graph it, you're not getting out of here alive. Well, how would I graph this problem? One of the easiest ways to graph a line is if you know its slope and y-intercept. But this equation isn't in that form. So what should I do? Well, how about we solve it for y? How do you solve it for y? Now, I'm going to skip steps with the understanding that you know what I am doing. To get y by itself, I'm going to first move the term with the x and move the constant. And then I'm going to divide everything by the number in front of y. If you're unsure of what I did in either of these steps, make sure you ask for help. Well, now I know that the slope is 2/3 and the y-intercept is -4. So if I'm going to go graph this, and now I've popped up my nice little graph, I'm going to start by putting a dot on the y-intercept, which is -4. And then I'm going to use rise over run to plot more points. Now the slope is positive, so that line better go up from left to right. So I'm going to go up 2 to the right 3. Up 2 to the right 3. Remember that you can also go the other direction. You can go down 2 to the left 3. As long as when you're done with this, you know that your line should be going up from left to right.